In order to determine if something is a function, you can always imagine that these are vending machines. X is the button that you press. Y is what comes out. So for the first one, we push button 1. We get item 0. We'll call it a Dr. Pepper. Since 1885, go DP. Then we push button 2. We get item 5 out. We'll call it a Diet Cherry Vanilla Dr. Pepper. So far so good, but there's an issue when we press button 3. Because sometimes we get item 2, sometimes we get item 3. That's like pushing one button, but sometimes we get Coke, sometimes we get Pepsi. But nobody ever really means to get Pepsi. So there's an issue here. This is not a function. A function is a properly working vending machine. So which of these other ones are also messed up? Well, C, because if we press button 2, we get 2 different things out, no good. Or that last one. You push 3, you get a Twix. You push 3, you get a Snickers. Well, that's fine, but we wanted a Twix. So B is the only one that is not messed up. That's our function. So that's how I recommend find all the ones that are messed up, and then whatever's left is the one that's good. Or you could always think if the X's are all different, it doesn't have a chance to be messed up. So that one must be good. X's don't repeat. That's the thing we're looking for. Okay, feel free to pause and practice with this one. Let's check it out. A, 2 buttons are messed up. That's out. B, button 5, that's jacked up. And D, this is just a minefield of broken vending machines. But lucky for us, one left over. That's the function. Nothing repeats. Therefore, it's consistent. Now, is it okay to have the same Y value in 2 spots? Definitely. It's just stocked with the same thing in 2 different locations, but you've seen that before. You press one button, you get Pop-Tarts, or you could press another button and get Pop-Tarts, but nothing's inconsistent. It's just giving the people what we want, so we're good. And one last one here. Feel free to pause. You know it. D, different X's, we're good. That's our function. Okay, how do you determine a function if you're given graphs? All you need to do is draw a vertical line anywhere on the graph, and it should only hit once. This one hits twice, not a function. The next one, vertical line, that hits 3 times. That's no good. But C, that hits once. That's our function. Because D, that hits twice, that's out. So look for the one, no matter where you draw the vertical line, it's always just going to hit once. But why is this a function? Well, let's label this point. The bottom is usually time. Let's say at 9 a.m., however high that graph goes is the temperature. Therefore, at 9 a.m., there can only be one temperature. We'll call it 70 degrees. But the issue is with A, because that would say at 9 a.m., it's 20 degrees and it's 100 degrees at the exact same time. Not possible, not a function. So functions will always model things that happen in real life there. Feel free to pause for that last one there. And it just so happens the first one we check, anywhere we draw a vertical line, hits once, that's our function. Which of the following values keeps this table a function? Now earlier I was saying you don't want the X's to repeat, but what if they do? Well, last week we had a bad breath day. We pushed button 1, we got some Trident gum. But then next week, same thing, bad breath day. Push button 1, we want some more Trident. We want to get the same Y value. That'll keep it consistent. That'll keep it a function. That's our answer. And one last one. Adding which of these points will keep this graph a function? The main thing is we just don't want points stacked on top of each other like we had over here. So let's plot these one at a time. 0, 2, we'll always start at the origin. The first numbers to the right, we're at right 0, up 2, put our point, there we go. But unfortunately, those are stacked. We draw a vertical line, passes through twice. That is not a point we want. Let's get rid of it. Okay, let's try the next. Right 2, up 1, start at the origin, 2 to the right, up 1, put our point. But once again, that one's also stacked. That's no good. And then 4 to the right, up 5, right 4, up 5. But we can see that one's also stacking, so that's no good either. So it has to be that last one, 6 to the right, up 3. That'll give everything its space. That'll make it a function. So these are the main types that show up on the GED. You got these? We'll see you in the next video. Toodles.